Okay, so several of you expressed some concerns about not understanding the z-scores in particular. So I thought I would make this little video that hopefully you will find helpful. Full disclosure, not a math teacher. I'm an 8th grade science teacher, but I did take an AP statistics class back in the day, and as I was looking over this in the book, it was kind of coming back to me. So I feel like I can explain it. So hopefully you find this helpful. And if not, I apologize in advance. So here we go. Okay, so we started with the basic mean, median, and mode. Oop, okay. So the mean is just the average. So to calculate the mean, you just add up all these numbers and then divide by the total number in your data set. So I'd add 7 plus 6 plus 4 plus 6 plus 3 plus 5 plus 6, and then I would divide that number by 7. The median is the middle number of your data. So if you put all the numbers in order like this, and you're just going to find the middle number. So that's the 1, 2, 3, 4, this. So 6 is our median. And then mode is the number that shows up the most. So just the number that's repeated the most times in your data set. So like looking at these, we have 6 3 times. We don't have any other numbers that were repeated more than that. So 6 is gonna be your mode. Standard deviation and variance. So standard deviation is just a measure of how far those values are from the mean. So if you have a small standard deviation, like maybe 5 or 10, that means that most of your numbers are really close to the mean. Now if you have a large standard deviation, maybe like 100 or something like that, that means that your numbers are really spread out. Your data is really spread out. So if you had the values like 1, 3, 2, 4, those numbers are all really close together, so you're going to have a small standard deviation. If you had numbers like 1, 57, 20, and 3012, those are really spread out. So you're going to have a larger standard deviation. Variance is just the standard deviation squared. Based on my research and reading, from what I can figure out, this is used for absolutely nothing. It is not useful at all for anything except by bougie researchers in a lab somewhere who care about this for some reason. So just know it's standard deviation squared and then forget about it. Skew is whether your curve is normal or whether it kind of leans to the left or the right. So here's a picture. So your normal distribution is going to look like this. So it's centered. If you folded this in half, then it would look the same on both sides. You have a positive skew. That means it's got a sharper curve to the left and then kind of a gradual curve over here to the right. A negative skew, you have a sharper curve to the right and then a long gradual curve to the left. So if the mean and median are the same, so if you get the same number for the mean and the median, your distribution is normal. It's going to be symmetrical. You're going to have this nice little middle curve here. If the mean is bigger than the median, then your skew is positive or it skews to the right. So that's going to be this one. So this is skewed to the right. It's a positive skew. So you have your, like you see, you have your median here and then your mean here. So your mean is bigger than your median. And the opposite is true for the negative skew. So if your mean is smaller than the median, then your skew is negative or it's skewed to the left. So you have this one over here. So you have your median here and then your mean to the left of it. That means it's smaller. So that's a negative skew. It's skewed to the left. So why do you need to know this? Why do you need to know about skew in a classroom? So standard deviation kind of comes into play. Maybe you want to take the averages of your students' test scores. So if you take all of their test scores, add them up, find the mean. If you have a large standard deviation, that means you're going to have students with like larger outlying scores. Like maybe your mean is 80, but you may have students making like 30s on one end and then like hundreds on the other. If you have a small standard deviation and your mean is like an 80, that means most of your students scored around there, like maybe in the 70 to 90 range, closer together. Z-scores, so this is the really confusing part, and this is where you kind of get hung up, and I think that's partly because the table in the book is really mean. So I have found an alternate table that's a little bit simpler to calculate. We'll get to that in a minute. So, but basically, z-score is a fancy word for how many standard deviations away from the mean a number is. So, if you're looking at your graphs here, you're going to have this blocked off into certain standard deviations, and the numbers will be a certain amount of standard deviations away from the mean. And so we use that to calculate the percent above or below the marker. So go back here and let's see if I can do this. Can I write? Will you let me write? Like actually on here? No. Okay. That would be too easy. There's probably a way to do this, but I don't know how. Okay, moving on. Anyway, so your percent under, so if your z-score is here, it's like, let's say it's one standard deviation above the mean. So you're going to find the percent of numbers below that z-score. So you want to know what all of this is over here, basically. So, if you're looking at, this is the practice exercise 7 that was due Friday. So I just used those same numbers. And I am assuming that you were able to put this into the SPSS program and crank out those z-scores. It does it automatically. You don't have to calculate. You just have to put in the data and then click the buttons. So your z-score for 16 is negative 1.59. And your mean is 90, or no, not 90. The mean is 20.36. So that means it's 1.59 standard deviations to the left. So if I'm looking at this graph, that means it's going to be over here. It's going to be over here to the left of the mean or below the mean, because obviously 16 is a smaller number than 20. The z-score for 21 is 0.23. Like 21 is pretty close to 20, so it's only 2/10 of a standard deviation above the mean or to the right. So that's going to be like right here. It's going to be like pretty close probably to that line. And then your z-score for 25 is 1.68. So if you go back here, it's going to be like over here-ish somewhere. So yeah. Now, to calculate those percents, this is where it gets complicated, so don't freak out. Breathe. We're going to get through this. So the z-score for 20 is negative 0.13. Then you look at the table. So you can look at the table B1 in the book, or you can look at this table that I'm about to give you here in a minute. So the z-score is negative 0.13. So if you look it up in table B1 in the textbook, it tells you the area between the mean and the z-score is 5.17. So if you're looking here, that means if you're, it's negative, so it's going to be over here. So that means that the area between the z-score and the mean is going to be 5.17. So that's the area between there. So since the z-score is negative, here, see it's negative 0.13, that means the number is to the left of the mean. And the mean is 50%. It's the 50% mark. The area between mean and z-score is a percent. So since the z-score is negative, that means it's 5.17% below 50%. And so since the z-score is to the left, it's negative. That means we subtract it from 50. So you take 50%, subtract 5.17%, and you get 44.83. So that means that 44.83% of the scores are less than 20. Okay, for the next one, we have a positive z-score. So the z-score for 26, 26 is bigger than 20, so it's got a positive z-score of 2.04. So that means it's 2.04 standard deviations away from the mean. And the area between the mean and the z-score is 47.93. So that means it's pretty far. That's a big number. So since the z-score is positive, that means the number is to the right of the mean. So if we're looking back at our little table here, so the z-score is going to be like all the way over here because it's like 2 point something. And so the area is 47.93. And again, the mean is the 50% mark. So you take that 50% mark, and since the z-score is to the right, we're going to add 50 to it. So we add this 50% to the area. So 50 plus 47.93, we end up with 97.93%. So that's how you do it if you are looking at the table in the book. So you got to do some math, a little bit of addition, subtraction, a little bit more complicated extra step. Now, this is a better table, in my personal opinion. It's a little bit less complicated because it has positives and negatives. So you don't have to remember all of this for the math and the scores. You just look at the table and find the number. So if we're looking at this table here, we want to know what percent. The z-score is 2.04. So we're going to scroll here, going to find, let's see, 2.04. So we go to 2.0, and then we're going to come across to 4, and you get 0.9793. So this table is giving you the area in a decimal instead of a percent. So you just multiply by 100, or you move that decimal 2 places to the right, you get 97.93%. So that means 97.93% of scores are below that number. So a little bit easier to understand. So say we have a z-score of negative 2.6. So we're going to go to negative 2.60 and right here, easy enough, move that decimal places 2 to the right, and you get 0.46%. So 0.46% is to the left of that number. So you see, we're not having to do all that math. All you have to do here is move the decimal point. So to figure out the likeliness or the percent above and below what separates it, you're going to do kind of the same thing, except this time we're going to be looking at that area and then find the z-score that corresponds to it. So, using the 5% criteria, you had the problem. The researchers were only interested in what's in the 95% versus the other 5%. So, we're using the 5% criteria to judge the likelihood of a score. The researcher identifies the score that divides the curve into two parts, one part containing 95% and the other part containing 5%. So what value separates, what value of z, so what z-score basically, separates the normal curve into these two sections. So that's 1.65. So if you're looking at the table in the book, the table B1 in the back of the textbook, you're going to be looking for the z-score with an area between mean and z-score of 45. So you're going to go look and you're looking for that second column to be 45. If you're looking at this table, you're just going to look for the z-score with the area closest to 0.95. So we go over here, we're looking for 0.95. Let's see, we get 0.95 is going to be right about here-ish. So you're looking at 1.65. Yeah, 1.65. Ta-da! And again, you have this 0.95, and then you multiply by 100. You just move this decimal two places to get 95%. Okay, and so from then, all you have to do to determine if the score is likely or unlikely is determine whether the z-score is bigger than this or smaller than this. So 95% of scores are going to be below 1.65. So any number that is smaller than 1.65 is going to be likely. It's a pretty likely score. Now, anything bigger than 1.65 is going to be the top 5% of the scores. So, based on their what they're looking at, what the parameters they're given, that's going to be unlikely. They're going to be less likely. So 95% of scores fall below 1.65 and then 5% in this area. So you would, you look at your percent, you just find the z-score. So let's say I have a z-score of 1.2. Is that likely or unlikely? So I'm going to go to 1.2. Is that bigger than 1.65 or smaller? So it's smaller, so that means it's likely. If we have a z-score of 2.35, that's going to be bigger. So this is bigger. That's the 99th percentile. That means that number's in the 99th percentile. It's bigger than 1.65, so that means it's going to be unlikely. And you would do the same thing with the second example, where you're looking at the z-scores for the top 2.5% and the bottom 2.5%. So you're looking for that, you're looking for the score that corresponds with 97.5. I think that's right. Math. So you're going to be right here. 97.5% on the nose. So that's 1.96. So that means in this case, anything above that number, any z-score higher than 1.96 is unlikely. So if you have a z-score of 1.72, so in the first example, that number would be considered unlikely because it's higher than 95%. But in the second example, it's smaller than your 97.5%. So that z-score is going to be likely. And then you do the same thing for the negative end. So here you're looking for the 2.5%. So 0.025. I think, yeah. So 0.025 here on the nose is going to be the exact same. So negative, except negative. So negative 1.96 in this case. That's going to give you the lower. So anything here is going to be smaller, it's going to be outside, it's going to be unlikely. So all of these are lower percentiles. They're very likely this person scores, if these were like test scores we were looking at, this would mean like this number, this person has scored in the bottom 0.5%. That means 99.5% scored better than them. So those would be unlikely. So anything between negative 1.96 and 1.96 is going to be likely, any z-score. And we're looking at z-score again. So you had to put that in the SPSS program to figure out what the z-score is before you are consulting this table. So you want to do that first because you don't want to do the like hard, long by hand calculation because that's terrible. And why do that when the computer can do it for you? So that's all I have for today. So I hope this was helpful for you. Thanks for listening. All right.